Welcome to Monochemistry. Today we're going to look at a slightly more complicated version of how to name compounds using the stock system. And this is necessary when you come across examples like the one I'm about to show you. This example right here. Sometimes using reverse crossover method isn't going to get you the right answer. And this is a particular case right here. However, using this method here will get you the right answer every time. So while reverse crossover is kind of a shortcut and you can use it a good chunk of the time, it will work, this is a better way to do it overall because it will give you the right answer every time. It just takes a little bit more work, but it's not too bad. Now, before we get started, I'd actually like you to take out your periodic tables, and I want you to find, I'm going to turn the page here in a second, I want you to find these metals that I'm about to show you, and I'm going to actually get you in the top right hand corner of each of these metals boxes on the periodic table to write the charges that they can possibly be so you have them. Okay, so these are the common multivalent metals. Okay, so what I'd like you to do is I'd like you to take it, like I said, take out your periodic table. I'd like you to find copper. Okay, find copper, find the box on your periodic table for copper, and see how copper has two likely charges that it can take when it forms ions. I want you to put both of those charges in the upper right hand corner of the box, just like I've done here in my beautiful straightly drawn copper box. Okay, now I want you to do that for all of these. Right, so you've got copper, iron, tin, lead, cobalt, gold, and mercury. Those are the most common ones, and what I'm going to try and do is make sure that all the quizzes and tests that you have, I'm going to use these ones. Okay? Now, there's two other ones I want you to write down for me. Okay, so first of all, I want you to find silver. Silver is not a multivalent, but it only ever takes a +1 charge. Therefore, I want you to write the +1 charge in silver's box at the top right-hand corner. So remember how I said most transition elements take a +2 unless otherwise stated? Well, this one never takes a +2. It only ever takes a +1. It's not a multivalent. You would never use the stock system. Okay, so you'd write silver chloride. It would never be silver 1 chloride because it only ever takes the 1 charge. It's always +1. It's never anything else. So be careful with that one, but write it down in your periodic table so you know. The other one I want you to find is titanium. Now titanium, just write it here, Ti, it can actually take a +2 or a +4. Okay, so make sure you make a note of that one as well. Okay, so take a couple of seconds and write these ones down, and we'll actually do the example problem in a second when you're done. Okay, so now that you've written down all the different multivalents and the other ones the other one, silver, which is not a multivalent that I talked to you about, now that you've got those written on your periodic table, you're ready to start. You're ready to start dealing with questions like this, okay? So the first thing you have to do is you have to really look at the question. Okay, so if you were given this, and basically the question is name this compound. If you're given this, first of all, you know it's ionic because it has, in Dora the Explorer land, you guys are saying a metal, that's right class, and a non-metal, right? That makes it ionic, okay? But more importantly, now that we know this is ionic, this metal is one of the ones that's in the transition elements. Okay, and if it's a transition element, there's a distinct possibility that it's a multivalent. Okay, so I'm going to work under the assumption that it is a multivalent and that I don't know the charge. Okay, so the first thing I'm going to do is I'm going to rewrite Ti here. I'm not going to put any charge, okay, because I don't know what it is. Now, the next thing I'm going to do is I'm going to take my nonmetal. Now, oxygen, if you look on your periodic tables, is in group 16. It always takes a -2 charge. Okay, so oxygen always takes a -2 charge. Now, I happen to have 2 oxygens, as you can see here. So, I'm going to rewrite this down here, and pick a different color here. You guys can try this too. It's a good strategy for now until you get the hang of it, just to write down these different things. So this is what I would do. I would first write down the oxygen, and there's 2 of them. If they each have a -2 charge, then the total negative charge of this compound is -4. Okay, now watch. Notice in the chemical formula, I've got 1 titanium and 2 oxygens, okay? So we know that this titanium oxide, whatever it's called, we don't know yet, in fact, any compound, unless otherwise stated, has a 0 charge. So if the total negative charge of this compound is -4, then what does the 1 titanium atom, what does its charge absolutely have to be? Yeah, it has to be +4 to balance out. Okay, now that I know what the charge of the titanium is, I can go ahead and name this. All right, so it's titanium, because it's titanium. So I'll say that. Titanium. Excuse my writing. Wow, that's really bad. You get the idea. Okay, and I know this one's going to be oxide because there are no prefixes in ionic compounds. Remember that when using the stock system, I always have to have a Roman numeral. The Roman numeral is in fact the charge of the metal ion. I'm going to write that. So it's 4, and 4 is IV, so it's titanium 4 oxide. Okay, and that is how you do these problems. We're going to do one more. I'm going to give it to you over here. I'm going to try one more question. Okay, so try this one. Pause it, try it, and then I'll come back to you and give you the answer here in a couple of seconds. Okay, so we have chromium. That's our wonky one. We have no idea what the charge of that will be, so we're going to leave it. And then we have nitrogen. Nitrogen is in group 15, and those take a -3 charge, so the total negative charge on this ion is going to be a -6. Okay? So the total positive charge also has to be a 6. Okay, but here, in this one, it's a little bit different than the last one we did. There are 3 chromiums, as it states here in the chemical formula. So that +6 charge is evenly distributed among 3 chromium ions. So if it's evenly distributed among 3 chromium ions, then each chromium ion has to be a +2. Okay? That makes the name of this thing chromium 2 nitride. There's lots of practice ones of these in your booklet that I gave you on writing chemical formula and naming compounds. So you should definitely practice a few more, and please don't hesitate to ask me in class if you are still having trouble with this. This takes a little bit of time and a lot of practice, guys. Don't give up on it. You get better at it as you go.